Hello everyone, so in the last videos we spoke about integers, floats and strings. Let's do a quick recap. Integers were whole numbers, 7, minus 32, 13 and so on. Floats are numbers with decimal points, 5.7, 7.1 and so on. Strings were a string of characters or a sentence of characters, and each of them had different kind of ways of interacting with them. Integers and floats can be added together, but they cannot be added to strings. But when it comes to multiplying, you can multiply integers with strings, but not floats, and so on and so forth. Now we will look at two other objects. It's booleans and also the non-object. The non-type object is just as it sounds. It's an object that has no value at all. It comes handy in certain particular situations. You as a beginner you will absolutely nearly never use it, but it's something to keep in mind that it exists. You have something that has no value at all that you can use in Python. But the one that is more interesting to us and that you will use more often is the Boolean objects. Booleans are a type of object that can have two values, that is either true or false. So you notice I've written it capitalized with a big T and a big F, and that's how you should do it every time, because otherwise Python will not recognize it. For example, let's create a box, a variable, loop is equal to true. But if we do it as def is equal to true, you see that in this case you get a squiggly line below it and it's not recognized. So you need to remember to capitalize the first letter. Character. Same goes for false. Step is equal to false, but fed is equal to false. It's not recognized. The squiggly line appears again. So in order to tell it that this is a Boolean with a value false or true, then you need to capitalize the first letter. So that's it. They can either be true or false, and then we have two kinds of operations that can be done with Booleans. It is either and or. And if you have, for example, false and false, then the result will be false. If we have false and true, it will be false. True and false, it's false, and so on. You can see this table for yourself. The second one is for OR operation. So false or false is equal to false. False or true is equal to true. This sounds a little bit complicated and a lot to remember, but the easiest way to remember is that if you have an AND operation, if only one of the objects interacting with one another is false, then the result will be false, okay? If only one is interacting with others. But if it is OR, if it is this one here, you need only one of the objects to be true for the result to be true. When you check it, let's see. With the AND, there are 3 falses, and each of them contain at least one that is false. Okay, one object that is false. But when it is that both of them are true, the result is true. The same goes, but in the other direction, inverted direction, goes for OR operations. You need only one of them to be true in order to get a true result. You see here it is true, true, and here we have both of them true, and the result here in this side is all of them are true. But in the case that both of them are false, like here, the result is false. So when we are using AND, only one of the objects needs to be false in order for the end result to be false. When we use OR, only one of them needs to be true for the end result to be true. So that's it. That still might be a little bit complicated, and it's like learning something by heart, and I don't like that. I like it when we explain things with real life examples. Let's imagine that we have a linear electric circuit. Linear electric circuits have one current that can flow through one direction, and there are different parts where it can either be connected and disconnected. So this one is an AND operation. So for example, let's say that this part that is either connected or disconnected is A, this part is B, this part is C, and this part is D here. And since this is a linear circuit, this is a line of AND operation. So it means A and B and C and D. Okay, A and B and C and D. So in order to have a more clear example in this case is that in order for the current, let me just move this out of the way like this. I took the line with me. I can just move it back. So in order for the current to be flowing from this side to the other side and the lamp to be working and shining light, we would need that everything here is connected. It is only one line to be disconnected that the lamp doesn't get any current. So for example, let's take the example that A is connected, okay? B is not connected, C is not connected, and D is connected. What happens here? Let's check. So the electricity starts off from the left side, from the battery, and it goes on and whoops, here it's connected, so it can still flow. But it ends up here. Here it comes to this point and it cannot move further and to light up the lamp. So the lamp in this case is shut off. In order to have it turned on, you need to connect these two parts as well, because that's the only way to have a steady line of current flowing from one side to another. That means in this case, when there are AND operations, you just need only one place where it's disconnected for the lamp to have no light. So let's write this example that I drew in VS Code. So we have A, B, C, and D, but B and C are disconnected. So A is equal to true, B is equal to false, C is equal to false, D is equal to true. So now we want to print out the result of A and B and C and D, because they were connected in a linear fashion, right? Good. So when we print this out, I push that button, it should start. Okay, let's give it a minute. Yeah, so end result is false. Why? Because we have at least one of these that is with a value false. So in this case, in order for this current to flow to the other side, we need everything to be true, true, true. And when we print again, let's see if the result changes. And of course it does, it's true, okay? So this case would be if we connect every single line here. So every single line here, like this. So in this case, of course, the electricity would be flowing directly to the lamp and the lamp would turn on, okay? The lamp would turn on. So this is the AND operation that is used on Booleans. Now we will talk about the OR operation. When we are talking about ORs, it's the OR operation. It's like an electric circuit that is connected in a parallel fashion. So here we have 4 distinct lines where the current can be flowing, but it depends on each of these places if they are still connected or not. So let's make up a case where, for example, like the last one, we have 2 connected and 2 of them are disconnected, okay? What happens in this case? The electricity comes this way, okay, from the battery, and it distributes through all the lines, okay? All the lines. In the 2 lines that are not connected, it ends up to this point and can go further, okay? It cannot pass to this other side here, but in the 2 other lines, we see that they are connected and the current keeps on flowing and can go directly to the lamp, and the result would be the lamp being turned on. But what if everything is turned off here? If any place, if any place here is not connected, that means all of them are not connected, then of course, even in this case, the electricity cannot pass this barrier of not being connected to the other side to the lamp, and the light would remain switched off. So in this case, when things are connected in parallel, we need only one of them to be connected, one of them to be true in order for the light to turn on. Let's turn back to the first example that we talked about. In this case, we have 2 that are connected, but even if there were only 1, we would have a turned on light. Let's check it in VS Code if that works just as we envision it right now. So we say A and B. So this is A, B, C, and D. We have AB as true and CD as false. So let's change it up a little. It's false. And then we have this one, false. Yep. And now it's not an AND. It was connected in a parallel fashion. So it's OR. When we print it out, the result must be true because we have at least one line that is connected to the lamp. So here it is, it's true. What happens if we make B also be false? Does it matter? Nope, it doesn't matter because we still have one line connected to the lamp. Let's check it out. We run it. Yep, it's running. Now we will see, yep, it's still true. But what happens if we disconnect A as well? If we disconnect it as well, we see that nothing can flow to the right side of the circuit. That's why the result would be no lamp being turned on, and the end value would be false, like in this case. Yeah, so this is all that you need to remember about AND and OR operations and Booleans. So Booleans are a type of object or value that can store two possible kinds of information. It's either turned on, the lamp is turned on, true, or false, the lamp is turned off. And yeah, those can be operated on by two different operations, AND and OR, and those are similar to electric circuits, that AND represent linear circuit, while OR represents a parallel circuit. So yeah, so that's basically all. I would like for you guys to make some examples in your mind and just test them out in VS Code, and also draw them like me like an electric circuit. It really helps the mind along to solidify these concepts. That will be all from my side, and we will continue on with the other parts of programming. The basics are done. This is the easiest part. It gets a little bit more complicated, but it's not that much more that you might believe. Okay, bye.